It's unfortunate when an authority having jurisdiction inspector is mistaken about a specific requirement. It's good when you stood your ground and were able to use the National Electrical Code, or NEC, to support the correct interpretation. This is how you resolve the immediate issue. By doing so, you may also have gained the respect of the inspector in the process. It is important to always remember that the NEC is the governing document for electrical installations. Even though authorities having jurisdiction may have their own local amendments or interpretations of the code, it is ultimately the NEC that dictates what is required. By being knowledgeable about the code and willing to advocate for its correct interpretation, safe and compliant electrical installations are more assured. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It's published by the National Fire Protection Association, or NFPA, and updated every 3 years. The NEC is adopted by most jurisdictions in the United States, and it serves as the basis for electrical codes and regulations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial. Understanding the NEC is essential for anyone involved in electrical work, from electricians and contractors to inspectors and engineers. It's also important for homeowners and business owners to be familiar with the NEC, as it can help them ensure that their electrical systems are safe and compliant. The NEC is a complex document, but it's well organized and easy to navigate. It's divided into chapters, articles, and sections, each of which covers a specific topic. The NEC also includes numerous tables, diagrams, and examples to help users understand the requirements. There are several ways to learn about the NEC. One way is to take a course or workshop offered by a local electrical training provider. Another way is to read the NEC itself and study the commentary and examples. It's also helpful to talk to experienced electricians and inspectors and ask them questions. It's important to stay up to date on the latest edition of the NEC. The NEC is updated every 3 years, and each edition includes new requirements and changes to existing requirements. By staying up to date, you can ensure that your electrical work is safe and compliant. The GFCI, or ground fault circuit interrupter, is a safety device that protects people from electrical shock. It works by monitoring the current flowing through a circuit and detecting any leakage current to ground. If a leakage current is detected, the GFCI quickly interrupts the circuit, preventing a dangerous shock. GFCI protection is required in many areas of the home and workplace, including bathrooms, kitchens, garages, and outdoor locations. It's also required for certain types of equipment, such as portable tools and appliances. GFCIs are available in several different types, including receptacle type, circuit breaker type, and portable type. Receptacle type GFCIs are installed in place of standard receptacles and provide GFCI protection for anything plugged into them. Circuit breaker type GFCIs are installed in the electrical panel and provide GFCI protection for an entire circuit. Portable type GFCIs are plugged into a standard receptacle and provide GFCI protection for anything plugged into them. GFCIs should be tested regularly to ensure that they are working properly. To test a GFCI, simply press the test button on the device. The GFCI should trip, interrupting the circuit. To reset the GFCI, press the reset button. If a GFCI fails to trip when tested, it should be replaced immediately. Electrical inspections are an important part of ensuring the safety of electrical installations. Electrical inspections are typically performed by local authorities having jurisdiction, or OJs, such as city or county inspectors. The purpose of an electrical inspection is to verify that the electrical installation complies with the NEC and other applicable codes and regulations. Electrical inspections are typically required for new construction, renovations, and additions. They may also be required when there is a change in occupancy or when there is a report of an electrical hazard. During an electrical inspection, the inspector will examine the wiring, overcurrent protection, grounding, and other components of the electrical system. The inspector will also verify that the electrical equipment is properly installed and that it is safe to operate. If the inspector finds any violations of the code, they will issue a notice of violation. The notice of violation will specify the violations and the corrective actions that must be taken. It's important to correct any violations promptly to avoid potential hazards and to ensure that the electrical installation is compliant. If you have any questions about electrical inspections, you should contact your local authority having jurisdiction. The authority having jurisdiction plays a crucial role in enforcing electrical codes and ensuring the safety of electrical installations. The AHA is typically a local government agency, such as a city or county building department. AHA is responsible for reviewing electrical plans, issuing permits, conducting inspections, and enforcing the NEC and other applicable codes and regulations. The AHA has the authority to approve or disapprove electrical installations. If an electrical installation does not comply with the code, the AHA can issue a notice of violation and require the contractor to correct the violations. The AHA also has the authority to shut down an electrical installation if it poses a serious hazard. It's important to work closely with the AHA to ensure that your electrical installations are safe and compliant. You should contact the AHA early in the planning process to discuss your project and to obtain any necessary permits. You should also schedule an inspection with the AHA before energizing the electrical installation. By working closely with the AHA, you can help to ensure that your electrical installations are safe and compliant. Grounding is an essential safety feature of electrical systems. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the overcurrent protection device, such as a circuit breaker or fuse. This prevents dangerous voltages from building up on metal parts of equipment, which could cause an electric shock. Grounding is required for most electrical equipment, including appliances, tools, and lighting fixtures. It's also required for the metal enclosures of electrical panels and equipment. There are two main types of grounding: equipment grounding and system grounding. Equipment grounding connects the metal parts of equipment to the grounding system. System grounding connects the neutral conductor of the electrical system to the grounding system. Both equipment grounding and system grounding are necessary to provide a safe and effective grounding system. Grounding electrodes are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. Grounding conductors are used to connect the grounding electrodes to the grounding system. Grounding conductors must be sized according to the NEC. Proper grounding is essential for electrical safety. If you have any questions about grounding, you should consult with a qualified electrician. Overcurrent protection is another essential safety feature of electrical systems. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. An overload occurs when the current in a circuit exceeds the rated capacity of the circuit. A short circuit occurs when there is a direct connection between two conductors, such as a hot wire and a neutral wire. Overcurrent protection devices are designed to trip or blow when an overcurrent condition occurs. This interrupts the flow of current and prevents damage to the electrical system and equipment. Circuit breakers are reusable overcurrent protection devices. When a circuit breaker trips, it can be reset by simply flipping the switch back to the on position. Fuses are one-time overcurrent protection devices. When a fuse blows, it must be replaced with a new fuse of the same rating. Overcurrent protection devices must be sized according to the NEC. The size of the overcurrent protection device should be based on the ampacity of the conductors in the circuit. It's important to use the correct size overcurrent protection device to ensure that the electrical system is properly protected. Wiring methods are the different ways that electrical conductors can be installed. The NEC specifies the acceptable wiring methods for different types of occupancies and applications. Some common wiring methods include non-metallic sheath cable, or NM cable, also known as Romex, rigid metal conduit, or RMC, electrical metallic tubing, or IMT, and liquid-tight flexible metal conduit, or LFMC. An M cable is a type of cable that consists of two or more insulated conductors enclosed in a non-metallic sheath. An M cable is commonly used in residential wiring. RMC is a type of conduit that is made of steel or aluminum. RMC is used in areas where the wiring is subject to physical damage. EMT is a type of conduit that is made of steel or aluminum. EMT is used in areas where the wiring is not subject to physical damage. LFNC is a type of flexible conduit that is used in wet locations. The NEC specifies the allowable uses for each type of wiring method. It's important to use the correct wiring method for the application to ensure that the electrical installation is safe and compliant. Electrical panels are the central distribution points for electrical power in a building. Electrical panels contain circuit breakers or fuses that protect the electrical circuits from overloads and short circuits. Electrical panels also provide a convenient location for disconnecting power to individual circuits. Electrical panels must be installed in accordance with the NEC. The NEC specifies the location, clearance, and grounding requirements for electrical panels. Electrical panels must be accessible and must have adequate working space around them. Electrical panels must also be properly labeled to indicate the circuits that they serve. It's important to keep electrical panels clean and free of obstructions. Never store anything in front of an electrical panel. The information and the rating of the overcurrent protection device is important, especially when working on or near electrical panels. Always make sure the correct breaker or fuse is used. Electrical safety is everyone's responsibility. By following safe electrical practices, you can help to prevent electrical shocks, fires, and other hazards. Always turn off the power before working on any electrical equipment. Use insulated tools and equipment. Never work on electrical equipment when you are wet or standing in water. Inspect electrical cords and plugs for damage. Replace any damaged cords or plugs immediately. Never overload electrical circuits. Use extension cords sparingly and never run them under rugs or carpets. Install GFCI protection in areas where there is a risk of electric shock. Test GFCIs regularly to ensure that they are working properly. If you are not qualified to perform electrical work, hire a qualified electrician. The NEC is a complex document, but it's essential for ensuring electrical safety. By understanding the NEC and following safe electrical practices, you can help to protect yourself, your family, and your property from electrical hazards. Article 210.8 of the NEC specifically addresses GFCI protection. The details outlined here require ground fault circuit interrupter protection for personnel in dwelling units. In bathroom areas, all 125 volt through 250 volt receptacles installed in bathrooms must have GFCI protection. Garages and accessory buildings at or below grade level also require GFCI protection for all 125 volt through 250 volt receptacles. Outdoors, all 125 volt through 250 volt receptacles must have GFCI protection, while any receptacle within 6 feet of the outside edge of a sink requires similar protection. In crawl spaces at or below grade level, all 125 volt through 250 volt receptacles require GFCI. Unfinished basements call for GFCI protection on all 125 volt through 250 volt receptacles. Kitchens demand GFCI protection for all receptacles serving countertop surfaces and any receptacle within 6 feet of the outside edge of a sink. Laundry areas also require GFCI protection for all 125 volt through 250 volt receptacles. These requirements aim to enhance safety and reduce the risk of electrical shock in areas where moisture or water is present. Ensuring proper GFCI protection is a critical aspect of electrical safety in residential settings. When an electrical inspector said that it had to be within 6 feet of the sink and then referred to the code book at 210.8, that section refers to dwelling units. It is important to clarify the specific requirements within the NEC and to understand how they apply to different areas within a dwelling unit. Ensuring compliance with these codes is essential for maintaining electrical safety and preventing potential hazards. The code provides specific guidelines for receptacle placement and protection in various rooms. The NEC is a complex document. It is always good to keep up with the latest changes. Fighting for what is right is important. Staying informed about changes to the electrical code, specifically the NEC, is crucial for anyone involved in electrical work, from electricians to inspectors. Regular updates and revisions are made to address new technologies, safety concerns, and evolving industry practices. Here are several strategies to stay informed. Firstly, subscribe to industry publications, whether online or print, that provide updates, analysis, and interpretations of the NEC. Secondly, attend training courses and seminars offered by reputable organizations. These sessions often cover the latest changes and provide practical insights into their application. Thirdly, join professional organizations like the Independent Electrical Contractors, or IC, or the National Electrical Contractors Association, or NECA. These groups often offer resources and networking opportunities for staying current with code requirements. Fourthly, participate in online forums and communities where electrical professionals discuss code changes and their implications. Sharing information and insights can be a valuable way to stay informed. Fifthly, check the NFPA website regularly for updates, announcements, and publications related to the NEC. The NFPA is the authoritative source for the code and related materials. Sixthly, engage with local authorities having jurisdiction to understand any local amendments or interpretations of the NEC. Building relationships with inspectors can provide valuable insights into code enforcement practices. By incorporating these strategies into your routine, you can stay informed about changes to the electrical code and ensure compliance with the latest requirements. Reviewing the codebook regularly is also a good thing to do. There are many updates and revisions to address the safety concerns as stated before.